Hello, welcome if you're new, welcome back if you're not. My name is Talia, and I'm an incoming fourth year student at UCSD studying chemistry. This YouTube channel is a fun way to boost your chemistry knowledge and reinforce what you may be learning in your chemistry classes. In this video, we are going to be calculating Q, which is similar to my previous video on calculating K, the equilibrium constant. So we will be going over the concept as well as doing a practice problem. And I hope that if you need help with that concept, you will keep on watching. Without further ado, let's get started. All right, so like I said, today we're going to be talking about calculating Q, the reaction quotient. So to give you a little bit of information about what Q is, I mentioned earlier how Q is similar to K. Q is basically the same as the equilibrium constant, but it uses initial concentrations or initial pressures. And we'll talk about calculating the equilibrium constant with pressures in a future video. But the big idea is that K uses information at equilibrium and Q uses initial information. And we can compare the value of Q to the value of K to tell us which direction the reaction will shift to get into equilibrium. So your reaction can shift two ways, towards the right or towards the left, and that comes from whether or not Q is greater than K or less than K. And the goal is for your reaction quotient to eventually equal K. So Q and K are calculated the same way. So we put everything with the products on the numerator and the reactants on the denominator. So if Q is greater than K, we have too much stuff on the numerator, too many products, and our equilibrium is going to shift left to make more reactants to bring down our overall value so that it gets closer to K. And the reverse is also true. So if Q is less than K, that means that the denominator of the fraction is too large and our value is too small, obviously. So the reaction or the equilibrium will shift to the right to make more products so that the value can increase. And if Q is equal to K, we have already achieved our goal and the reaction is in equilibrium. Okay, so now we're going to do a practice problem. I give you the following equilibrium expression. We have 2SO3 is in equilibrium with 2SO2 and O2. I gave you initial concentrations. The concentration of SO2 is 0.40 molar, SO3 is 1.2 molar, and O2 is 0.1 molar. And we have a K. So our goal is to calculate Q and determine which way the equilibrium will shift. So before we get started, I am going to rewrite the expression for calculating Q, which is going to be the same as calculating K. And I'm going to write it specifically for this reaction. So Q is going to equal the concentration of SO2 squared times the concentration of O2 divided by the concentration of SO3 squared. Now that we have done that, we are going to calculate Q, plug in the values that we have. So Q is going to equal 0.40 molar squared, and then the concentration of O2 is 0.1 molar divided by 1.2 molar squared. And you can plug that into your calculator. And that is going to get us 0.01. Our K value is 15.0. So we have Q is less than K, which means we have too much on the reactants, and our reaction is going to shift to the right or to the products. Going to shift to the right, make more products, and the goal is going to be to increase the value, so to add more to the numerator, and the products are on the numerator. So if we make more products, we are going to have a larger value and eventually reach equilibrium. That was the end of this video. I hope you'll join me next week as we start talking about ice tables, which is going to bridge the gap between initial concentrations, which we just talked about, and equilibrium concentrations, which was in my previous video. If you have any comments, questions, or concerns, feel free to leave them in the comment section below, and I will do my best to answer them. I hope that I can see you in a future video, and good luck with learning chemistry.